Okay, so the second part of working with sine, cosine, and tangent requires us to find angles. So that's what we're going to look at in this exercise. We're going to be finding an angle given the sides. I would argue that finding an angle given the sides is probably the one more commonly used than the other way around, simply because you'll know the lengths, but you may not know the angle you need to set on a miter saw to cut a crown molding or to cut a railing to make a railing line up the way you want on a stair. But you would know the rise and the run of the stairs. So I think sometimes angles are the one that maybe we use most. It just depends on the application. Angles you would use most if you were doing cuts. But if you were doing site layouts with elevations and figuring out dig depths and that kind of thing, you're going to use finding sides the most. So it's just depending, I guess, on which one you use. So the first thing we're going to do is just a quick calculator check, just to make sure you still remember what you're doing with your calculator. If you're doing these lessons back to back, you probably don't need to do this and you can skip through. But if it's been a day or so since you've looked at it, make sure your calculator's good. So the first thing you want to check is make sure it's on degrees. You'll see that DEG or perhaps just a D in your calculator, so you can watch for that. And we want to figure out what angle would make a side ratio that makes this true. So in order to find that, remember what we used before. To get the angle, or theta alone, our angle is going to be equal to, we do the inverse sine. So we always do that sine minus 1 of 0.3152. Okay, so sine minus 1 is when you hit shift and sine. You have to do the shift with it. We only do that when we're looking for the angle, and you should have an angle 18 degrees. Cosine of 0.7 of cosine of an angle is 0.7541. So our angle is going to be the cosine minus 1 of 0.7541, which gives us 41 degrees. And then for the last one, the angle that would give us a tan ratio of 2.525 is going to be equal to inverse tan, 2.525, gives us an angle equal to 68 degrees. So just a really, really quick calculator check. If that's good, the rest of the lesson is going to go very easy for you. Now we're going to dive right into some examples. So you used SOHCAHTOA last time. Hopefully we still remember the ratios. We're going to write them down again as we go. How do we use SOHCAHTOA in order to find the measure of the angle X in degrees? Well, the first thing I want you to do is we're going to list our ratios, and I want to list them in their abbreviations. Here we are. So SOHCAHTOA. So we're just writing this down so that we have all the ratios in front of us. The first thing we're going to do in order to solve this triangle is we're going to label our sides, just like we did the last time. So 10 is our hypotenuse, 6 is across from X, so it's the opposite, and then our adjacent isn't labeled. Then what I do is I go back and I look at my ratios. I want the angle, so that's my first letter I'm looking for, but I need to find which ratio has opposite and hypotenuse, and we can easily see that that's the sine ratio. So we just fill in what we know. The sine of our angle is equal to opposite over hypotenuse. Filling that in, the sine, and you can use theta or you could write in sine of X, is equal to opposite side is 6 over 10. Now this is where it's really important. When you do this fraction part, keep extra decimals. If the question has extra decimals, in this case we don't. So we have sine X equals 0.6. Now in order to get X alone, we do that shift sign. You don't have to write as many steps down as this. I'm writing down all of the little steps so you can see the thought process that goes through. Sometimes I forget to do that. So we do shift sign 0.6 and you would get 37 degrees. For most of our calculations, just rounding to the nearest degree will be appropriate unless it's asked otherwise. So nice and easy. The biggest thing to remember is when you want an angle, it's that shift sign. Okay, remembering that. Throw T on here. Remembering that's going to be important. Example 2, what's the measure of angle x in degrees again? So we've got our lovely triangle here, labeling our sides. We have opposite, we have hypotenuse, and this must be adjacent. Which ratio do we use? If you write this down enough times, you won't forget it. The ratio that uses opposite and adjacent is the tan ratio. So labeling your sides and then finding which ratio uses both of the sides that either the side you want and the side you have, or both of the sides that you have, depending on what you're calculating. So we're going to use tan. So the tan of an angle is equal to the ratio of the opposite side divided by the adjacent side. So the tan of angle x is going to be equal to, opposite is 4, adjacent is 8. So x will be equal to, and we do that shift tan of, I'm going to put 0.5 in because 4 divided by 8 is going to be 0.5. And putting that in your calculator, you get angle x is equal to 27 degrees. I think most people find this one easier because there's less rearranging. You just have to remember to press that shift tan and keep extra decimals if there are any. I have 2 quick examples left. This is a really quick lesson. What is the measure of angle x in degrees? So again, label your sides. So we have angle x, this is adjacent, this is the hypotenuse, and here's my opposite. All right. So if I'm going through, I have adjacent hypotenuse, this one uses cosine. So the cosine of an angle is equal to adjacent divided by hypotenuse. We can work that O in. Cosine of x is going to be equal to adjacent is 5 divided by 10, which happens to be the same as 0.5. So if I want to find x, x will be equal to, we do that shift cos, that cos minus 1, with 0.5, which x gives us 60 degrees. Again, nice and straightforward. The next question actually asks us to solve the triangle. So this is one of those times where it's going to be convenient to remember what I told you before about the angles in a triangle adding up to 180 degrees. We can use that information. We also want to find out the missing side here. So we're going to have some choices we can make in order to find them. I'm going to start with finding the angles, and I'm going to leave the side to last for a reason, but I'm going to start with calculating the angle. So let's calculate angle A first. Okay, we're going to ignore B for the moment. Angle A is what I'm focusing on, so this is my focus. 12.4 is my hypotenuse. 5.4 is opposite A. So that's my opposite side, and my adjacent side is the missing side. All right, so if I want to find angle A, which ratio would I use? Which ratio uses O and H? Well, you don't have to go very far. SOH, CAH, TOA. To find A, we're going to use sine. So the sine of A is going to be equal to, the opposite side goes on top, 5.4 over 12.4. Okay. Sine of A is equal to 0.4355. If I want to find angle A, I do shift sign, the inverse sign of the decimal. You'll see I kept extra decimals. That's going to matter. It can make our angle off by a couple degrees if we only rounded it to 0.4. So we want to keep those extra decimals. And angle A is equal to 26 degrees. Okay, so we've got that labeled. Now, what about angle B? Well, we know that all the angles in a triangle add to 180. So I know 2 angles. Let's figure it out. 180, take away, I know there's 90 degrees there, and I know the other one is 26, leaves me with 64 degrees equals B. So this is 64. 64 plus 26 and 90. So that just leaves us with some really easy math. Why would I do that instead of erasing everything for A and doing SOHCAHTOA again to find angle B. Well, I'm less likely to make mistakes subtracting from 180 than I am rearranging my sine-cosine ratio. So that's a really good tool. Now, the very last piece is the missing side. And I want you to think about the best way to calculate the missing side. Now, I'm going to get rid of a little bit of information here. Let's come back too far. I'm going to erase a little information. And we'll fill in the bare minimum. Okay. So I'm just going to fill in what we know. So we've calculated a couple things. So we calculated that B is 64 degrees and A is 26 degrees, and this is our 90. We want to find out what's this missing side. Well, I know two sides of the triangle. I know hypotenuse and I know the base. What would you have used to calculate that last week? You would have used Pythagorean theorem. And in this case, I would suggest using Pythagorean theorem. Don't use SOHCAHTOA. Why? Well, the reason we don't want to use SOHCAHTOA and we want to use Pythagorean theorem is I'm less likely to make a mistake. I don't have to use a number that I've calculated. What if I made a mistake calculating angle A? That's going to have my side incorrect, even if I use the formula perfect. So by just using the known information, that 12.4 and the 5.4 of Pythagorean theorem, we can mix them together because they're both right triangles. SOHCAHTOA only applies to right triangles. So that means anytime we're a place where we can use SOHCAHTOA, we can also use Pythagorean theorem. So let's plug it in. A squared plus B squared equals C squared. Well, our hypotenuse is C, so that's going to be 12.4. And I'm going to say A is X. That's the side that I want, so X squared. I'm not using A because we had an angle A, plus 5.4 squared. If you put that into your calculator, I'm going to let you do the rearranging. So X squared is equal to 12.123. I'll get back to my screen. 124.6, and then we take our square root. Taking that square root is really important, and X is equal to 11.2. Okay, so 11.2, it doesn't matter, meters, feet, whatever the original units happen to be. So fairly straightforward. So the biggest thing with the last question is we used a little bit of extra. So we only had to use SOHCAHTOA once. We could use the fact that the angles in a triangle add to 180 degrees to help us out. And then we also use Pythagorean theorem in order to find the missing side. So don't be afraid to keep going back to Pythagorean theorem. Just because we finished with Pythagorean theorem in terms of what it looks like for your assessment, we're not going to be going over and over and over that again. You will find you will have to use it in some cases, or it might be the better solution to use in some of your cases. If you have any questions at all about solving those questions, don't hesitate to let me know. Once you finish this section, because SAM is a little tricky in the way that it marks these ones, I have an assessment for you to complete and hand into Dropbox, and hopefully I'll have the rest of your assignments back to you by the time I start getting those ones in.